In the previous video, we were talking about the Swing related applet and AWT based applet. Okay, AWT based applets are still used, especially when only very simple user-friendly interface is required, not a big one. And both AWT and Swing based applets are still valid. JApplet inherits the applet class, so you have to understand both the applet class as well as the JApplet class. Okay, if you are only interested in Swing applets, still you have to understand the all things. We will proceed further with the upcoming PPTs. That when creating swing based applets, some additional constraints apply, and these are described later in this course. Okay, when swing is covered, when you will understand about swing, we will think about it or discuss about it. Okay, for more information regarding building applets with using swing, we will see the upcoming chapter, that is 29. Firstly, we will see the applet basics. Chapter 13 introduces the general form of an applet and the steps necessary to compile and run the applet. Okay, so we will still review this information again. All applets are subclasses, either directly or indirectly, of applet. Applets are not standalone programs. They run within either a web browser or an applet viewer. Okay, so either directly or indirectly they inherit the applet class, first thing. And second thing, those are not standalone programs. Either they will run on web browser or an applet viewer. Okay, the illustrations shown in this chapter were created with the standard applet viewer called applet viewer by JDK. Okay, so you can also use in your PC, in your laptop or desktop, any applet viewer or any web browser you like. Okay, there is no main method in applet. So, few applets have the main method, but the execution does not begin with a main method. Execution of applet is started and controlled with an entirely different mechanism. That mechanism we will see further. Output to your applet window is not performed by system.out.println like a window-based application we have seen. In non-swing applet that we will see in chapter 29, instead of swing applet that we will see in chapter number 29. Now, these applets, those we are going to see in this chapter, output is handled with various AWT methods, like drawString, which outputs a string to a specified XY location. Okay, so X coordinate and Y coordinate we will provide, and drawString will draw a particular string or output at the particular location you provide. Input is also handled differently. Okay, than a console-based application. Swing-based applets use the swing classes to handle user interaction, and they are described later. Okay, so to understand the swing-based applet, you have to first understand what is swing, and introduction to swing is done in the later chapter, that is 29. To use an applet, it is specified in an HTML file. You have to learn the HTML basics so that you will provide the HTML file, and then in that you will provide your applet. One way to do this by using the applet tag in HTML file. Object can also be used, but the current Sun certification currently recommends the applet tag, and this is the tag used by examples everywhere. Applet will be executed by Java enabled web browser when it encounters the applet tag within the HTML file. Okay, so automatically it will be open. First of all, whatever Chrome or any Firefox or any web browser that is Java enabled on your PC, when you will double click on the file that is having the applet tag, HTML file that is having the applet tag, will be run on the web browser that is Java enabled. Okay, when it encountered the applet tag within an HTML file. To view and test an applet more conveniently, simply include a comment at the head of your Java source code file that contains the applet tag. Okay, when you include the applet tag, your program runs more conveniently. Your code is documented with the necessary HTML statements needed by your applet, and you can test the compiled applet by starting the applet viewer with your Java source code file specified as the target. Okay. Well, you can test the compiled applet by starting the applet viewer with your Java source code file. So this is the example of such a document. Here, applet code, my applet with 2200 height 60. So this type of window will be created. This comment contains an applet tag that will run an applet called my applet in a window that is 200 pixels wide and 60 pixels high. Because the inclusion of applet command makes testing applets easier. All of the applets we'll see now onwards will contain the appropriate applet tag embedded in a comment. Whenever you include an applet tag in your HTML file, your program runs more easily and more conveniently, and you will understand it better. So, whichever examples we will see shortly will have the applet tag included. Okay, applet class. Applet class defines the methods shown in the table upcoming. Applet provides all necessary support for applet execution. Okay, so applet class is a bunch of all necessary functions and interfaces and methods such as starting and stopping. All the methods, all the support it is having. It also provides methods that load and display the images and methods that load and play audio clips. Okay, so everything is available in applet class. Applet extends the AWT class panel. Okay, in turn panel extends container, which extends component. Okay, so component is a base class of container. Container is a base class of panel. Panel is a base class of AWT, and AWT is a base class of applet. And in your program, that is, we are creating applet of, you will extend the applet class. These classes provide support for Java's window-based graphical user interface. Applet provides all of the necessary support for window-based activities. Okay, so all these classes, those we have seen, like component, container, panel, AWT, and applet, all support for Java's window-based graphical user interface. So this way, it supports all window-based activities. Okay, so now we will see the methods defined by applet. First method is void destroy, called by the browser just before an applet is destroyed or terminated. Your applet will provide this method if it needs to perform any cleanup prior to its destruction. Okay. Any cleanup means anything that it wants to do before the destruction. Accessible context, get accessible context, return the accessibility context for the invoking object. Applet context, get applet context, returns the context associated with the applet. String get applet information, returns a string that describes the applet. Audio clip get audio clip URL, returns the audio clip object that encapsulates the audio clip found at the location specified by URL. Audio clip get audio clip URL string clip name, returns an audio clip object that encapsulates the audio clip found at the location specified by URL and having the name specified by clip name. Okay, the URL get code base returns the URL associated with the invoking applet. Then URL get document base returns the URL of the HTML document that invokes the applet. Okay, URL of the HTML document, that is document base. Then image get image URL returns the image object that encapsulates the image found at the location that is specified by URL. Image get image URL string image name returns an image object that encapsulates image found at the location specified by URL and having the name as image. Local get local returns a local object that is used by various local sensitive classes and methods. String get parameter string parameter name returns the parameter associated with parameter name. Null is returned if the specified parameter is not found. String get parameter info returns a string table that describes the parameter recognized by the applet. Each entry in the table must consist of three things, that that contain the name of the parameter, description of its type and or range, and an explanation of its purpose. So what is the parameter info? It is a string table that describes the parameters. Okay. Each entry must consist of 3 strings that contain the name of the parameter, description of type or range, and explanation of its purpose. Init, void init, called when applet begin execution. It is the first method called by any applet. Boolean is active, returns true if the applet has been started. It returns false if as applet has been stopped, that is not active. Static final audio clip, new audio clip URL, returns an audio clip object that encapsulates the audio clip found at the location specified by URL. This method is similar to get audio clip except that it is static and can be executed without a need for an applet object. Okay, so here in this case we do not need the applet object. Okay, void play URL if an audio clip is found in the location clip is played, so that song will be played. Void play URL string clip name if an audio clip is found at the location specified by URL with the name specified by name, clip is played. Void resize dimension, resize the applet according to the dimension specified by dimension. Dimension is a class stored inside java.awt. It contains width and height. So you will specify new width and new height for the applet window that will be created. Void resize width height, resize the applet according to the dimension specified by width and height. Okay, so instead of creating dimension object, we are directly specifying width and height, and here we are creating first dimension object and then we are specifying the width and height. Then final void set stub applet stub object makes the stub object the stub for the applet. This method is used by the runtime system and is not usually called by your applet. A stub is small piece of code that provides the linkage between your applet and the browser. So what is stub? Makes the stub object of the stub used by the runtime system and not usually called by your applet. Okay, so it is not directly connected to your applet. A stub is a small piece of code that provides the link between applet and a browser. So it is a connection, stub is a connection between the applet and the browser. So show status string, display string in the status window of the browser or applet viewer. If the browser does not support a status window, no action takes place. Okay, so string will be displayed in the status window of the browser or applet viewer. Start and stop. Start is called by the browser when an applet should start or resume the execution. It is automatically called after init when an applet first begins. Okay, and stop called by browser to suspend execution of the applet. Once stopped, an applet is restarted when the browser calls the start method. Now we will see the applet architecture. Applet is a window-based program. As such, it is architecture different from the console-based programs like system.out or println shown in the first part of this course. If you are familiar with the Windows programming, you will be right at home writing applets. If not, there should be some concept you will be understanding. First, applets are event-driven. First thing you have to remember, we won't examine event handling until the following chapter. It is important to understand the basic or general way how the event-driven architecture impacts the applet design. Okay, so what is event-driven architecture plus how it handles the applet architecture or applet design. Applet resembles the set of interrupt service routine. Okay, interrupt service routine set will be resembled by the applet. Now, applet waits until an event occurs. Okay, something will happen with the applet window. Applet will wait or stand alone. Runtime system notifies the applet about the event by calling the event handler that has been provided by the applet. Like if any button is pressed, anything is minimized or maximized, and like this. Okay, radio button is clicked or any text is entered, so that some event is user interaction is occurring between applet. Okay, that will be notified to your applet by the runtime system. Once this happens, the applet must take appropriate action and then quickly return. Okay, something should be there as an output. This is the crucial point. Your applet should not enter a mode of operation in which it maintains control for an extended period. Okay. For the most part, what you have to, what is the main thing? Your applet should not enter a mode of operation in which it maintains the control for an extended period. So period is limited. It must perform specific action in response to events and then return control to the runtime system as soon as possible. Okay. So whenever like user is pressing the button, like something, it is clicking on the button, the color of applet should change. So it should change immediately. Okay, as soon as possible. In those situations in which applet needs to perform a repetitive task like displaying a scrolling message across its window, you must start an additional thread on it for execution. Okay, so extra thread will be required in this case if the repetitive task like scrolling is required. The user initiates interaction with an applet, not the other way around. Okay, applet do not start interaction with user. User initiate interaction with an applet. It's the important thing. In a non-windowed program, when the program needs input, it will prompt the user and then call some input methods such as read line. Read the input from keyboard, not the way it works in an applet. Okay. Instead, the user interacts with applet as or when she wants. Okay. These interactions are sent to the applet as events, and that event will be handled and applet will respond. When the user clicks the mouse inside the applet window, mouse click event is generated, and whatever you have written in on the mouse click event, it will be performed. If the user presses a key while applet window has input focus, key press event is generated and its output is operation is take place. As you will see in the upcoming chapters, applet can contain various controls such as push button and checkboxes. Okay. When the user interacts with one of these controls, an event is generated. While the architecture of an applet is not easy to understand as that of console-based program, Java makes it as simple as possible because Java is a simple language to understand. If you have written programs for Windows, you know how implementing that environment can be intimidating. Java provides much cleaner approach to by using this, we will master the applet very quickly. Now we will see the applet skeleton. All but the most trivial applets override a set of methods, very common method that provides the basic mechanism by which the browser or applet viewer interfaces to the applet and controls its execution. Okay, so there are some basic methods you have to understand. Init, start, stop, and destroy. All applets, it applies to all applet and defined by applet class. These methods are very important and very common. Default implementations for all these methods are provided in this upcoming videos. Applets do not need to override these methods. They do not. Okay. If it is doing something on start, if it is doing something on stop, it is compulsory for it. Okay. If it is not doing, if it is not using that particular event, then it will not be used. Only very simple applet will not need to define all of them. Okay. AWT based applets such as those discussed in this chapter will also provide one more method, that is paint method, which is defined by the AWT component class. This method is called when applet's output must be redisplayed. Okay. Every time the applet output like applet is minimized and something other like your Chrome or your Eclipse is maximized, applet will go into background. Next time when you minimize the front window, that is Eclipse, applet will be again in the foreground so that its window should be again paint. Okay, so it will again paint, so button will be again paint, radio button will be again paint, checkboxes will again paint, and so on. For that purpose, it is compulsory to override that paint method in the AWT based applet. Okay, so swing based applet use a different mechanism to accomplish this task. Okay, 5 methods assembled into the skeleton shown here. So AWT and applet are imported over here. Applet code is applet skeleton. Width is 300, height is 100. Okay, This class is extending applet, init, initialization, start or resume. Okay, it is just for the sake of understanding how it is written. Public void stop, suspends the execution, void destroy, perform shutdown activities, and pain. Although this skeleton does not do anything, it can be compiled and run. When run, it generates the following window. Okay, when we will run it using applet viewer. This is the output. Okay, this is the applet. This is the name of applet, applet skeleton. Applet has been started, status of the applet. Every time applet stop, applet restarted, applet resumed, this type of status will be displayed over here. And since we have done nothing in this applet, the window is white. Okay. So in this way, we have started and completed the applet basics. In the upcoming videos, upcoming session, I will explain you more about the applet in detail. That is AWT based applet, so that you will enjoy the appleting. Applet is very simple thing and very interesting because it is interactive. It is like not like in console based applications and programs. When generally speaking, when you will understand the applet and its user interface, you will be more happy to learn it because it is not that much boring like console based application. Since still console based applications are important because without understanding the console based, you cannot fully learn the Java programming language. But applet is more interesting than console based applications. So that when you will learn the applet, you will find it more interesting to learn it, and you will be more happy to learn. Okay, so enjoy the session regarding the applet. Enjoy this chapter and revise if you are required anything that you have not understood yet. Go to back and again see the video. Okay, so I will meet you in the next session with some few topics. Okay, so meet you in the next session. Thank you so much.